Hello, this is William Dodds for video assignment number 2. My problem or my situation is two vehicles are traveling along the same road, a bicycle and a car. The bicycle has a constant velocity of 5 meters per second, and the car has an initial velocity of 17 meters per second and decelerates at a rate of -3 meters per second squared. The question is, what is the minimum deceleration distance so that the car never hits the bicycle? Now, to solve this problem, you'll have to realize that in order for the car not to hit the bike, that the bike's position needs to always be ahead of the car's position. And for this to be a minimum, it means that the velocity of the car will equal the velocity of the bike at some point, and that it'll be less than the bike at that point. The two equations that you'll need for this, actually, just to show that, you'll have some car's velocity beginning at 17 and slowly decreasing, and the bike stays constant, and it'll intersect at some point, and that will be your time. So to solve this equation, or to solve this situation, you need to use the following equations. V squared equals V naught squared minus 2a minus s naught. And this, since we know V naught, and 2a, and s naught, we can find the deceleration distance so that the final velocity will be 5 meters per second. And once we know this final distance, we can work out the time needed for the bike, or rather the initial position of the bike, so that the car never reaches the bike. So we know that we know the initial s of we know that the final s of the car should be the final s of the bike, and we know the time from our velocity versus time graph, and we know the velocity, so that'll give us the initial position of the bike. So just to show you what this setup would look like, we have the bike's position as a function of time, 5t plus SO, and the car's position as a function, which will be SO is 0 for the car, minus the deceleration, plus the velocity. And the final solution will be 24 meters per second, or 24 meters.